Here we go. So first of all, let's take a look at example 1. Let's go ahead and graph x squared. We know that x squared is going to be 0 squared is 0, right? We're going to go 1 squared is 1. 1, 2. 2 squared is 4, right? 1, 2, 3, 4. 1, 2, 3 squared is 9. I'm going to go up 1, 2, 3, 4. 5, 6, 7, 8, 9. Okay? So I'm just putting in the original function. And this is something everybody can do. Even if you say, I can't do math, Mr. Davis, sure you can. You can do 1 squared, 2 squared, and 3 squared, right? And you know that negative 1 squared is a positive 1. You know that negative 2 squared is a positive 4. And you know negative 3 squared is a positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this is our parent function. This is our parabola. It's a parabola. And this is my parent function. We call it the parent function because it is the most basic of the x squared equation. And then what we're going to do with it is we're going to move it. So let's take a look at what we have. So now, if we want to graph g of x, we're just going to take this graph and we're going to move it. We're going to do a translation. So it's called a translation. A translation. We're going to go 2 units up. Right? That's what we're going to do. We're going to go take our graph. We're just going to move our graph up 2. So I know its vertex is right there. Okay? So it has a vertex. And the vertex is here because we're going to take this graph and just move it up 2. So from my vertex, let's do the same thing. From the vertex, we'll still do a 1, 1. We'll go over 2, and 2 squared is 1, 2, 3, 4. From the vertex, we'll go over 1, 2, 3, and then 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And we know that it has points on the other side because it's symmetrical. We'll have a point here, and a point here, and a point here. So, there's my new graph. I just took my x squared and I translated it 2 units up. It still is going to have a line of symmetry right down the middle, right? It has a line of symmetry right down the middle. And that line of symmetry is x equals 0. That's my line of symmetry. My vertex is at the point 0, 2. Okay, I'll step back. Okay? So all we did was we took our parent function and we just moved it up 2. That's all we did. It's still the same 0 squared, 1 squared, 2 squared, 3 squared, except for it's just moved up 2. We have a vertex now not at 0, 0, but our vertex is at 0, 2. That's where the bottom point is. Line of symmetry still goes through the middle of it at x equals 0. And we translated it 2 units up. Thumbs up? Thumbs up? Okay, let's look at example 2. So, example B, first of all, we have a stretch. The function we have is automatically a stretch. So we've got a vertical stretch right at the bat, okay? We do have a vertical stretch. So my parent function is going to look like this. Okay, you ready? 0 squared is 0 times 2, right? Now here's what Ben did. Okay, Ben did a nice job talking through this, okay? If I go over 1, 1 squared is 1, right? 1 squared is 1, except we're going to be twice as tall. Twice as tall. So if I go over 1, 1 squared is 1, but I'm not going to go to 1. That's there. I'm going to go twice as tall to 2. If I go to 2 squared is 4, right? So I'd go to 1, 2, 3, 4. And I'm going to rest my pencil there for a second because I'm not going to go to 4 because this graph's twice as tall. It's a vertical stretch. So instead of 4, I'll go 5, 6, 7, 8. Okay? 3 squared is 9, so I'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, except it's a vertical stretch by 2, so instead of 9, I'm going to go up to 18, which is off my paper, right? It's like way the heck up there somewhere, okay? So then all I can do is go and take a look at the other points because it is symmetrical. So this is all I get. Okay, now we haven't moved it. This is my original. Okay, this is my original. This is my plain old 2x squared. Its vertex is at 0, 0. What we're going to do with this, though, we're going to take this graph. You watching? I know you're watching. Sure you're watching, Brian. We're just going to take this graph, take the 2x squared, that's this graph. We're just going to bring it down 2. That's all. We're going to bring it down 2 units to get our answer. So if I bring it down 2 units, this vertex goes down 1, 2 to here. This point right here comes down to 1, 2. We're coming down 2 because we have a translation 2 units down. This point right here comes down 2, 1, 2. Okay, we'll do the same thing on this side. This point comes down 1, 2, and this point comes down 1, 2. Okay, so I took the entire graph and I just moved it down 2 units. Same shape, it just moved down 2. There it is. There's my new function, translated 2 units. So it has a vertical stretch of 2, and it is going to be then translated down 2 units. Thumbs up. Okay. Turn the page. Tell me when you're ready to turn the page. This is not that hard. It comes down to, can you just graph the parent function, right?
And if you want to
turn the page, go to the page. Okay, now, so on A, so tell me, what do you guys think? Tell me, how are we going to graph A? What's going to happen? In your words. Cody? Shh. Cody? Shh. So in your words, what's going to happen? Look at this little equation. I got an x squared minus 7. What am I going to do? What am I going to do? Look at this. So here's what Tim said. Put your x squared graph in and then move it down 7. So we could do this in 2 steps. But that seems like a lot of extra work, doesn't it? We know that if we're going to take it down 7. Now listen, here's a shortcut, right? Let's just go straight down to negative 7, okay? 1, 2, 3, 4, 5, 6, 7, okay? Let's just go straight down to negative 7. And then we know the shape is the parabola, right? And that's when we do our 1, 1, our 2, 4, and our 3, 9. But we'll do it from here. It's probably easier just to go straight to it instead of trying 2 graphs. Draw 1 graph and bring it down. Let's just do it from here. So I'm going to go 1 squared is 1. Go back to the vertex. Go back to the vertex. Go over 1, 2. 2 squared is 1, 2, 3, 4. Go back to the vertex. Go over 1, 2, 3. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And we know, of course, it has a line of symmetry, right? That goes right down through the middle. So that we know it has another point that's symmetrical to it, another point over here that's symmetrical to it, and another point that's symmetrical. So that's it. Here's my parabola. Okay? So all we did is we took our graph down 7. Okay? Now, how about B? Am I okay? How about B? Vertex, so real quick, the vertex here is at 0, negative 7. Okay? Okay, shift it over. Now what about this one? Shh. Stop talking, boys. What about this one? It's got a negative x squared. It's got a negative x squared. So if it's a negative x squared, it's going to be upside down. Upside down. So instead of being a smiley face, this one's going to be a frowny face. But we don't say upside down in math because that's not a math word. We say we're going to reflect over the x-axis. So instead of calling it upside down, the math terms we're going to use is we're going to say we're going to reflect over the x-axis. Okay? So, before I do anything, to make this easy for me, let's find the vertex, okay? So the vertex of this graph is going to be at positive 1, right there. There's my vertex, okay? There's my vertex right there because of the 1, okay? So I go right there. So my vertex of this is going to be at 0, 1. So I'm going to go ahead and put my point at 0, 1. There's my vertex. And instead of going up, we're still going to do the 1, 1, 2, 4, 3, 9, but we're just going to do it upside down. You okay with that? So from my vertex, if I go over 1, 1 squared is 1. If I go back to my vertex, I go over 1, 2, 2 squared is 4, but we're going upside down. So I go 1, 2, 3, 4. Okay, I go back to my vertex. If I go over 1, 2, 3, 3 squared is 9, right? So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. We know it has a line of symmetry which goes through the middle of it, which gives me the other points on the other side of the parabola. Okay, so I get a reflected point here, I get another reflected point here, and I get another reflected point here, and here's my parabola. So we reflected it over the x-axis, and then we moved the graph, translated the graph up 1. We reflected over the x-axis, we did a translation 1, okay? How's that? Okay, now let's do a couple more of these. Let's go to page 82, okay? Go to page 82. And I want you guys to try number 1 on your own, okay? Try number 1 on your own. Okay, a little hint, you might want to put your x-axis all the way down here. Okay, and if it all doesn't fit all the way, but I want you to try number 1, okay? Graph function, okay? I want you to do this. Try and do this one on your own, okay? Okay, I want everybody to try number 1. Try g of x equals x squared plus 5. I want you to try this on your own, okay? Okay, give it a try. I'm going to wait a couple of minutes before I go ahead and give you the first hint. Okay, I want everybody to try number 1. Yeah, Josiah is totally right. We're going to start at 1, 2, 3, 4, 5. So we've got a translation 5 units up. And then from here you do your 1, 1 and your 2, 4 and your 3, 9, right? I don't think 3, 9 is going to fit, but I can go off my graph, right? So give it a try. Okay, I want everybody to try and graph the parabola.
It's going to go off the page.
Yeah, it sure is. So I might only have a couple of points. I might only have this. I might only get this, right? Is that what you guys got? Yeah, but the shape's right. Well, it's not a very good shape because I'm not much of an artist, am I? Okay. But I basically moved the whole graph up 5, didn't I? And then from here, I still did my 1, 1, my 2, 4, okay? Everybody get that? Thumbs up, I want to see. Thumbs up. Okay, I see some thumbs up. Okay, good job. Jesus gives me, Chewy gives me a thumbs up. I like that. Okay, Josiah's got that. Okay, now let's shift down to number 3 because number 3 is a little bit harder. So in number 3, just a hint on putting the graph in. Go ahead and put your x-axis way up here, okay? On number 3, just a hint. Put your x-axis way up here, okay? X-axis, y-axis, okay? So first of all, where is the vertex? Where's the vertex on this one? Where's the vertex? It's at -2, okay? I agree. So the vertex is at -2. So we're going to go down 1, 2, and start there, okay? And it's upside down, isn't it? It's also upside down, or it's a reflection over the x-axis. Okay, it's upside down because of the negative. And it's going to be 3 times as tall. Stop. It's going to be 3 times as tall. So instead of 1, 1, I got to go 1 all the way down to 3. Instead of 2, 4, I got to go 2 all the way down to 12. So watch me do this. 1, 1 would be here, over 1, 1, right? Upside down. 1, 1 would be here, but I'm not going to go to 1, 1. I'm going to go to 1. I got to go down 1, 2, 3. It goes all the way down to here. If I go 2, 4, I'd go 2, and I go 1, 2, 3, 4, but I got to go all the way down 3 times to 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe right about there, okay? So we know it's symmetrical. So we get the points on this side. It's super skinny and tall in the upside down fashion. Okay. All right, let's do one last one. Let's do number 4, and then I think we're probably good. You guys agree after 4? I think we're good. Okay. Yeah. Let's do 4. So before we do anything, where's the vertex? There you go. The vertex is at 0, -4. Totally right. Okay. So when I put in my graph, I got to make sure -4 is there, right? Okay. All right, so I'm going to start there. Okay. Josiah's totally right. Let's go to -4 and put our vertex, okay? So our vertex is going to go down to -4. Okay? And now, it's going to be, Ben, Bryce, it's going to be half as tall, right? Half as tall, right? So I normally would go 1, 1. I'd normally go 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. But I'm putting these in really lightly because I'm going to go half as tall. I'm not really going to graph these at all. I'm going to graph half as tall. I'm not really going to graph these points at all because I'm going to do it half as tall, okay? So instead of going up to 1, I'm going to go half as tall. Instead of going up to 1, 2, 3, 4, I'm going half as tall, which is 2. Instead of going up to 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm going to go half as tall, which gives me a 4.5. 1, 2, 3, 4.5. And of course, it has points on the other side of the line of symmetry, which makes our graph looks like this. Okay. All right. Thumbs up, everybody. Okay, you guys got it? Okay. So let me stop recording.